need to backtrack a little bit, and I want to show you, just to reiterate one more time, how when we're talking about mixed numbers and we're talking about improper fractions, how those two things are equivalent. They mean the same thing, because then in today's lesson we're going to talk about creating equivalent fractions. Okay, so I think the easiest way to do this is a picture. And some of you yesterday, as you were working on your homework at 2:30, you were stumped on number 2 because you had a picture and you didn't know how to write a mixed number from it, and you didn't know how to change that to an improper fraction. So I want to do a quick demonstration of how we would do that. Then we're going to move on to today's lesson of equivalent fractions. So by the time that we get done with our lesson today, you should know how to, when given a fraction, you should know how to write me 2 more fractions that are equivalent to it. Okay? Equivalent, again, what does that mean? Equal to, same value. Okay? So, let's look at a picture. If I have, and I'm just going to use rectangles. Pretend like they're all the same size and they're all cut perfectly into the same amount of space in each section. Okay, I'm going to pretend like I'm shading this whole box. I'm going to pretend like I'm shading this whole figure. And I'm going to pretend like I'm shading these two. Okay? Alright, so what we have to be able to do, we have to be able to look at this picture and we have to be able to identify what it is as a mixed number and what it is as an improper fraction. Okay? So, when I write this as a mixed number, the first thing I have to remember is a mixed number is a whole and a part. So when I look at this picture, I see 1, 2 shapes that are shaded entirely, right? All of this is shaded and all of this is shaded. There's my whole number. Okay? Now I'm looking at the one down here where only part is shaded. Only 2 sections are shaded. Okay? I have 2 sections shaded out of a total of 3. So, this picture represents 2 2/3 as a mixed number. Most of you could get that far. The part that stumped you is, how do I look at this picture and how do I change it to an improper fraction? How do I write this picture as an improper fraction? That's what stumped most of you. Well, you could have cheated or used your resources, however you want to look at it, and say, oh, this is 2 2/3. I know how to change that to a mixed number. I'm sorry, to an improper fraction. So I could use my math skills, multiply 3 times 2 and get
6.
Add 2 and get
8.
Same denominator. Okay? Let's see if we can use just this picture and come up with 8/3. Okay? How many of you know how to do this? Not all of us. Okay, when I look at this, when I have just a picture and I have to give an improper fraction, the first thing I need to do is I need to count all the boxes that are shaded. Not my total number of boxes, but all the ones that are shaded. So I have 1, 2, 3, 4, 5, 6, 7, 8 that are shaded. Oh, there's my numerator. Okay? Then I'm going to look at one single hole. Okay? So I can look up here at this top box. How many sections is this hole broken into?
3.
There's my denominator. So to write it from a picture to an improper fraction, I count the number that are shaded. That's my numerator. I look at one hole, how many ever sections it's broken into, that's my denominator. If you look, no matter if I used the picture to get it, or if I used my original mixed number to get my improper fraction, I got the same thing. I'm sorry? So, I'm going to give you a picture real quick because equivalent fractions won't take us too long. And you're going to write me an improper fraction and a mixed number on it. Okay? And just pretend like they're all the same size. Again, my skills are not excellent. I know. I didn't want them to jump the gun. I'll show it to you in just a second. Here's your picture. Write me an improper fraction and a mixed number. I saw one person on their entire board that reduced the fraction. 2/4 is the same thing as 1/2. Job report. Alright, let's look at this very quickly because I did have 2 or 3 that were still kind of showing that they were a little uncertain. When I look at this, I have 1, 2, 3 whole figures shaded. When I look at my last figure, I have 2 out of 1, 2, 3, 4 sections shaded. 3 2/4. When I get my improper fraction, I'm counting all the ones that are shaded. So here's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If I look at one whole, it's broken into 4 sections. 14/4. Those should have been your 2 answers. Good? Always start by counting your wholes, because if you think of a mixed number, you have a whole and you have a part. So always look at your wholes first, count those, do your fraction part, then you can always take this and convert it to a mixed number, or I'm sorry, an improper fraction. If the counting the shaded ones and then figuring out how many parts there are doesn't make sense to you, just convert this to an improper fraction. By 4 times 3 is 12, 13, 14, keep the same denominator. Okay? Alright, you'll get it. So, building into equivalent fractions, obviously, we know that we can have an improper fraction that is equivalent to a mixed number, right? And that means the same thing. Stand up if you agree. Every improper fraction has an equivalent mixed number. Everybody should be standing. Okay? Alright, sit down. Today our focus is going to be mixed numbers. As I was telling you earlier, by the end you need to make sure that you know how to find equivalent fractions. Let's start basic. Okay? Everybody likes things to be fair in life, right?
Yeah.
If your brother gets a new pair of shoes, you better get a new pair of shoes, right?
Yeah.
Okay? If your brother gets a watch, you know you all want a watch, right?
Yeah.
Okay? We like things to be fair. Fractions are the same way. When we talk about equivalent fractions, they want everybody to be treated the same, to be treated fairly. Okay? So, whatever we do to one, we have to do to the other, right?
Yeah.
When we create equivalent fractions, I'm going to start very basic. This should be a review skill for you, but I want to go over one, kind of walking through the process, and then you're going to help me come up with a few of them, okay? When we create equivalent fractions, we're going to look at our numerator and multiply it by any number that we want. I would suggest starting really small, okay? So I might say I'm going to multiply 1 times 2. 1 times 2 is? 2. Whatever I multiply the top by, I have to?
Multiply the bottom.
Because we're going to share. Everybody's going to get the same thing, right? 2 times 2 is?
4.
4. Okay? If I look at this, this tells me I have 2 parts in one whole and one is shaded. Do you agree with that picture?
Yeah.
This tells me I have 4 parts and 2 are shaded. Do you agree with that picture?
Yeah.
Do you see how they're equal?
Yeah.
So, we can multiply the bottom and the top, the numerator and the denominator, by any number that we want, as long as whatever we do to the top, we do to the bottom, and vice versa. Anytime that we are finding equivalent fractions, okay? You can also divide the top number and the bottom number, as long as you're dividing them by the same. Let me give you an example. If I start with a fraction that looks like 6 over 8, okay, I can create an equivalent fraction two ways. Paul, are you with me? Okay. I can say, I want to multiply this top one by 3. If I multiply the top by 3, what do I have to multiply the bottom by?
3.
6 times 3 is?
18.
8 times 3 is?
24.
18 over 24 is equivalent to 6 over 8. I can also find an equivalent fraction by dividing. Again, I have to know multiplication facts because I have to know common factors. When I look at 6 and I look at 8, they're both even, so I know I can divide them by 2. If I divide the top by 2, what can I do to the bottom? 6 divided by 2 is?
3.
8 divided by 2 is?
4.
3/4 is equal to 6/8. Here's my question. Listen to what I say and then listen to my question. 3/4 is equal to 6/8. 18 over 24 is equal to 6/8. Is 3/4 equal to 18 over 24?
Yes. Nothing so. Yes.
Verify it. Prove it. Tell me how. Raise your hand. Tell me how. Using what you know about equivalent fractions, Hope. Yeah. She used division. She looked at this fraction here and she noticed, well, I can divide both of these by 6. 18 divided by 6 gives me 3. 24 divided by 6 gives me 4. Okay? You could have also looked at it the reverse way. 3 times 6 is 18. 4 times 6 is 24. Okay? So, whether you're taking your fraction down or you're making it larger, those are equivalent fractions. They're all equal as long as your math is correct. Okay? So, what if I give you something that looks like this? And you have a blank right here. Tell me what it is. On your board, show me what it is. 2 over 7 is equal to 10 over what? I have to ask myself, what did I have to multiply 2 times to get 10? What did I multiply my 2 times to get 10?
5.
If I multiply the top times 5, what do I have to multiply the bottom by?
5.
My answer should be 35. There's a lot of chatter. Okay, let's do another one like that. That one stumped some of you. Fill in the numerator. I have to look for a relationship. Okay, I'm seeing a lot of good answers. When I look at this, 18 divided by 2 equals? If I divided the bottom by 2, I must be equal and divide the top by 2. 6 divided by 2 is?
3.
3 would have been your missing answer. No, it's not the same as a half. It would be 1/3. But I'm proud of you for being on top of trying to reduce it. Alright, your last brain buster before you move on to guided reading. I am sad that there's this much noise. Here's your problem.